was what?
Why did you say something about that?
The domain is the x-coordinates used to create a function. The range is the y-coordinates you're using to create a function. So, looking at this graph, I want to find the domain and the range. Okay, so that's kind of obnoxiously bright, sorry. Okay. I hit this thing. Alright, so what you're looking at, when you look at the graph, you're thinking, what are the x-coordinates they're using to create this graph? Is it just a few x-coordinates? It's a lot, because since it's a solid line, it's every single x-coordinate, every little tiny fractional value. So my recommendation is, when you are finding domain, since you're doing x-coordinates, look left to right. How far left does this graph go? The farthest left it's going is -6. Okay, and since it's solid, there's no breaks, how far to the right is it going to extend? It's going to go on forever, isn't it? There's no end point here. So if we write the domain, this is where your interval notation comes in. You said left side was -6, right side was infinity. Tell me about brackets and parentheses. Since that's closed, and that's your domain. You went from -6 all the way to infinity. Imagine that. Okay, so now range is y-coordinates. So instead of thinking left to right, what do you have to think on range? Do you go up to down? Do you go big numbers to small numbers? Down to up, yeah. Or low to high. So ask yourself, how low does this function go? It's going down forever, so it's the lowest point can be -infinity. How high does it go? And it's not the highest point on the y-axis, it's the highest point the graph ever makes it to, which is supposed to be up there at 5. And once again, I would have parentheses on infinity, brackets on the 5. Not bad, right? Why is the next one going to be a touch more fun? Yeah. It's got 2 different pieces. So we're going to do it as 2 different pieces. Since there's a gap in here, that means we're going to have to do 2 different intervals. So doing this one, domain, what's left? I should count for you. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's -10. That's -5. So the leftmost point is what? -10. And this first piece goes unbroken until it gets to -5. Brackets or parentheses? Parentheses. They're open. Yeah, they're open circles. Okay. Then I go, oh, but there's more over here. So where's the leftmost part of this one? 0 going right forever. So 0 to infinity. 0 with a bracket. Now, I have to take these combined with these. What symbol did you use?
The union.
A union. It's the union of those.
Hey, how come we didn't put brackets on the first one?
Because they're open circles. They're not closed.
I got you.
So now, range, same thing. Starting from bottom going up, the first place we hit anything is here, which is what, 1, 2, 3, that's -4. Okay, so how high does it go up before it breaks?
-2.
It gets to -2, so I'm going to go -4 to -2, bracket or parenthesis on the board. It's -4, that's a bracket. But the 2's are open, parentheses. Then I'm going to union it, and I'm going to go up here. What's the lowest point on this piece? 3, with a bracket, because it's closed in, and it goes to infinity. And you
Hey, I got a question. How come you put an arrow on it? You said mathematicians at this level never put arrows on it.
Because I wasn't thinking about it, and I threw an arrow. You're correct. I should. Anymore, we don't throw arrows on them. We just extend them outward, and everybody knows it goes forever.
Okay,
Okay, so I'm not mentally.
sorry, I just had to.
That's okay. I'm not mentally back in my game totally either. All right. So now that was graph. Domain is more fun when I give you the actual equation of the function.
Oh, no.
Nice to meet you. Just warn you now. We're doing domain today. We're doing domain all next time.
Hey, I thought you said this stuff.
This is where it gets a little tricky. I'm about to make you a chart. This chart also goes on the bottom of your journal. There's a chart down there too.
Oh, really?
She's a liar. Mark, can I go to the bathroom quick?
Yes, you may.
Your life dead.
I know it doesn't like to draw too fast and it doesn't like me. I didn't draw that one that fast.
Beautiful.
Lovely.
I don't know why we don't record it. Why do we
Okay, you need to live and die by this chart. Okay, when working domain problems. Okay? We'll preface that, all right?
Yeah.
Okay, there's going to be 4 types of problems I'm going to give you, and we're going to try this with. The first kind is going to be an ordinary polynomial. Do you know what I mean by an ordinary polynomial?
It's like 3x squared plus 2x.
Yeah. Normal. Just normal, multiple terms, x to some nice whole number power. That's your standard polynomial. Okay, so when you're doing this domain, you're asking yourself, what numbers can I put in there for x? Because domain is the x values you're allowed to put in a function. The easiest way to do these is to ask yourself, is there anything I can't put in there? Is there any number you could not put in there for x that would give you a bad answer, meaning you've got something undefined, imaginary. If I put 0 in there for x, 0, 0, 0 minus 5, I'll get -5. Is that a bad answer?
Yeah.
No, you get -5 is an okay number. It's a normal number. It's not imaginary. It's not undefined. Okay. Infinity, okay. Infinity. If I put infinity in there, I'm going to get infinity, but that's not a... That's so, infinity is a real part of the real number line. So, okay, point being, a polynomial, you put anything in there. There aren't any restrictions on it. And so, therefore, the domain on a polynomial, you put any number in there you want. How do I write all numbers? You can either write, I don't care which one you use. You can do -infinity to +infinity, or you can use the all real symbol, whichever one you prefer. I don't care. Okay. The second kind is a rational function. Rational functions are fractions. I'm talking fraction problems. It'll look something like this. That's an x. Okay, so it's a function of fraction. Okay, what's the one thing you can never have in a fraction?
A negative.
Zero?
Zero where? Yeah. So, out of the fraction, your denominator, the denominator can't equal 0. You can never have a denominator equal 0. Okay, so, how am I gonna figure out what makes the denominator equal 0?
Don't you dare. Really awesome.
Okay, your answer is gonna come out to be x can't be
A lot of trouble.
some number.
That's why I said,
Okay, so that's what we're gonna get, x can't be some number. How am I gonna find out what numbers it can't be? So how do I have to figure out what makes the bottom equal 0. How do I figure out? I do highlight. Oh, but how? Factor, thank you. Boyle's reversing of it.
she learned that in chemistry the other day. We had our math in chemistry the other day.
I mean, you're just gonna sit there, all you're gonna do is you're gonna factor that. That's x minus 6 and x plus 4. So what numbers can it be?
-4. No, 6 and -4.
So yeah, so you would say your domain is x can't be 6 and x can't be -4. When we could write that as interval notation, but who wants to write negative infinity to -4, union with -4 to 6, union with 6 to infinity? That's insane. If it's just a couple numbers we don't want, we just write x can't be those numbers and call it good. So, fractions, no zeros on the bottom. Okay, here's the part you're going to be excited about. Okay, by even root, I mean square root, fourth root, sixth root, eighth root. Odd, cube root, fifth root, seventh root. So, example of an even root would be something like square root of x plus 2.
Oh, they'll call it English. Guess what? I read a whole AR substitution. Why? Because I have to write a freaking read. Of all classes.
Okay, there's your example. I'm running out of time and you need to hear this. You can't go off on wait. Okay, what's the difference in what can happen inside an even root and what can happen inside an odd root? Even, okay, on the outside, but can you have, what kind of numbers do you have to have on inside a even root? I don't want imaginary numbers.
You can have negative numbers.
I cannot have negative numbers in there. I want only real numbers. I can't come out with anything that makes me negative on the inside, because square root of a negative number is imaginary. So you can't have any negatives. So it must contain positive values. Okay, whereas an odd root, do you have to have positive numbers in an odd root? Can I have the cube root of -8?
Yeah. That would be 2.
Cube root of -8 is -2. You can have odd numbers in odd roots, or negative numbers in odd roots. It's okay. So down here, you can have positives or negatives. There aren't any restrictions down here. But if it's an even root, you got issues. So this one will still be infinity to infinity or all reals, whichever you like. Okay. Now, no, what you have to do is you have to find the domain, you have to figure out which numbers make it positive, and this is where y'all going to be so excited to hear this. Does anybody remember back, it was in September a year ago, you did it again on the test, where I made you figure out where things were positive and negative? The pluses and minus things?
Oh, is that number line thing?
It was that number line thing.
I used the 8 on that.
Trust me. You have to do what's called testing points.
Oh.
It's not that bad.
What's up, man?
Actually, guys, I want to make this one trickier since I'm running out of time and I can kill two birds with one stone.
1 minute.
Okay, suppose I've given you that. We're actually going to test points. I need to remind you how to test points. Ignore the roots for right now. You're ignoring the roots. And you're going to go, alright, where will this thing contain positive values? If you'll recall, what you did is you got a number line. That's okay, I can go over it. It doesn't scream at me. And I'm going to have to finish this in 5 minutes. Okay, so I need to know, first you have to figure out the numbers on the number line are where it equals 0. How do you figure out where that equals 0? You factor it. This factors is plus 3 and minus 1. Okay, where does each of those equal 0? Negative 3 and positive 1. So those are the numbers you put on your number line. Okay. Then this is where you test points. You picked a number somewhere below negative 3. What's the number below negative 3? Negative 4. Okay, you put it in here and you see if you're going to come out positive or negative. If I put negative 4 in there, negative 4 plus 3 is negative. So I would get a negative times, if I put negative 4 in there, I would get a negative. And a negative times a negative is a positive. So I know that everything below negative 3 will come out positive. Okay. A lot of the time it does alternate. Once you figure out one, it goes positive, negative, positive, negative. Okay. Anybody remember how you know it's going to do that?
If it's something about y equals.
Your powers on your x's. If all of those are first powers, it'll alternate. If you have x squared, x cubed, if you start getting exponents on your x's, you'll have to test every spot because it might go plus, plus, minus. But if it's all x to the first powers, it will alternate. So we know this one's going to go positive, negative, positive.
Can I still drop this class?
No. Well, actually, yeah, you can until Tuesday. So now, here's how you get your answer. You look at it and you go, I need it to be positives, right? Said positive values?
Yes.
So my answers would be these and these.
Yeah. That'd be
And
negative infinity to negative 3.
so yes, negative infinity to negative 3. You can equal 0 in a root, so it would be bracketed. Then union with this one starting at what number? 1 to infinity. You got your, and that would be your actual solution. Now, I'm going to post one more. What if you have a problem that has a root and a bracket in it?
Then you wait till
You're doing both. It can equal 0, but you also have to test points.
your equalness sign.
I will post some examples of those.
Yeah.
Do not panic if you have some trouble with this